Okay, so I'll be talking today about a project that I worked on actually with my dad, which has been a lot of fun. It's also with my advisor and a couple other colleagues from my MIT. And this project is probably a little more closely to stuff related to stuff that I do rather than what he's classically done. But he mentioned yesterday he's very broad, so I think this kind of still fits in. And one little anecdote for the project is he kept bringing up like multiple times over several weeks. This project's about voting. It's about a new or somewhat recent voting paradigm, liquid democracy. And he kept saying, what do the voters know? Like, what are we saying when we model their behavior? And I thought the answer is obvious, but I think like thoroughly thinking that through and run it down well, it actually like improved the paper. So his take was quite important and relates to that stuff. So but before I start, I'll begin with our classic history of relationship with my dad slide. So mine is actually not as long as many of yours, but I think maybe proportional to my life, it's pretty good. So it started pretty early. This is quite young. I'm like 3 years old learning to ride a bike, but even quite young, we were doing math together. I remember we'd like go on hikes, and I'd always give me a math problem. And I was one of those kids, and he'd come to my like class at elementary school and talk about things, and I thought I was very cool when that would happen. So I guess maybe I was somewhat of a weird kid, but I really like that. And it started early, and then a couple of times. Started in middle school. I started doing some more like math competition stuff. There's like a big like phase transition moment where I'd start like being a little faster than him at some middle school math things. So again, very exciting for me. Although I guess it shows that middle school math competition is not super related to being a good expert in the field. Um, and then in college, we went to the same university in Toronto, and one thing I really remember is after doing a like Putnam math competition, is I'd immediately after spent like 6 hours working on math that day on a Saturday, and then immediately biked up to my parents' place. They were living there that semester, and we like went through all the problems together. Figured out what we got right and wrong. So I don't know, just lots of great memories there. And then it's even gotten more closer to stuff I do now. This was my very first conference, and something really cool was that my dad was also there. So just like David, he helped me with my very first slides. I think they were pretty bad to start with, and he turned them into something much more acceptable. It was actually like a positive experience. Although now I don't use Beamer anymore. I like Keynote a lot better. But it's yeah, he really helped me start on this journey, which is a lot of fun, which has kept going even to now. So this is a much more recent picture from just this winter, and I don't know. We get to work on projects together. I like see him at conferences. I keep meeting people that he knows, and they always say like the nicest things about him. And um, yeah, so it's been so much fun to work with him, and thank him for all the stuff he's done for me. And yeah. Anyway, so now let me tell you a little bit about liquid democracy. So what is liquid democracy? It's a voting paradigm. So it's just sort of a different way that we can do voting, and I'll relate it on a spectrum to two voting systems we're probably quite familiar with. So the first is direct democracy. So this is a situation where when you want to make a decision, everybody votes on this decisions. These are things like town halls or referenda, where just you want to take a vote. Everybody in the society comes together and says what they think. On the other side of this is another thing we're very familiar with, representative democracy, where essentially someone votes on our behalf. We first like decide. The way I'm going to phrase it is we sort of delegate our vote to someone else. We as a group in a district say, this is going to be a representative. We all sort of delegate our voting power to this one person, and then they vote on our behalf. And each of these two things, I'm going to think of it as like a spectrum. They sort of have advantages. Direct democracy, people are very involved. They really feel like their voice is getting heard. They get to directly talk about an issue. But representative democracy is maybe more feasible on a large scale, and you really might not be comfortable with all issues. I mean, you might feel like someone else is actually better. Maybe if you had the time, you would do all the research, but you don't. So you delegate your vote to someone that you think will vote on your behalf. Like, had you done the research, it would be better. And liquid democracy falls right in the middle of these two. It sort of claims to have benefits of both. So I'm not going to like argue all the philosophy behind this, whether it's actually better or worse. We'll be focusing on like one very specific part of it. But the claim is that it's going to get some advantages of both. So the way that it works is if you have this society of people, When it's time to make a decision, when it's time for the society to vote on something, everybody will have two choices. They can either directly vote, just like in direct democracy, or they can delegate their vote, kind of like representative democracy. But the difference is that they can delegate to anybody in the society. So there's not just like a set group of representatives and only the one that gets elected actually has the voice. You can just choose like, I delegate my vote to this person. So this is what this picture is showing here. An arrow is like, I delegate my vote to this person. And if a person, and these delegations are transitive, so this person right here, so these people delegate to this person, this one here, and this person's gonna vote on behalf of all four of them. So when they vote, they sort of have a weight of 4 rather than a weight of just 1. But after that, we just sort of collect all the votes together, just like direct democracy. So this is the basic idea, sort of introduced maybe 20-ish years ago. The history is not super clear. But it is something that's actually used in practice, not like a ton, but it's gaining some traction. So these are a couple of political parties, I think like Argentina and Australia, and the biggest ones in Germany, where they sort of, their idea is they promise, like obviously we can't change the democratic system, but if we get elected to parliament, the way that our parliament members will vote, we'll sort of run a liquid democracy, virtual liquid democracy among our constituents, and vote on their behalf. So sort of like at least a couple of votes within the parliament are decided by a liquid democracy. And this is like a much bigger change. I'm not really advocating for big political shifts like this, but it's also being used on smaller scales at like company-wide things. You sort of want to make a company decision among shareholders or executive. There's lots of places where voting is used. It's not just political. And again, it's been used in Google. My co-author is really up to date with the latest things. It's used in a bunch of like French companies now for some reason because she's French and she's been talking about it. But it is gaining some traction in some places. People sort of think it's cool and like using something new. But the question is, how can we actually compare these different voting systems? What's the right one to use? What are the benefits and disadvantages? So I'm going to focus on like one very specific part. I'm not claiming this is like the reason to use one or another, but I think it's like a cool model from voting, or from very classic voting theory that you can use to evaluate different voting systems. So this is known as the epistemic approach. It's actually different from epistemic logic that White Hat has actually worked on, but it's a very classic name. It's not. We didn't just steal this name from stuff that he's done. It goes back actually like 250 years-ish, back to Condorcet, who was one of the original voting theorists. And the way Condorcet's setup worked like this. So this is just a way to analyze voting. So you'll have n voters, and they're voting on a binary issue. So there's just two outcomes that they get to vote for one or the other. And the assumption is that sort of one is the correct outcome and one is the incorrect outcome. So there's an objective answer. So this doesn't really fit with maybe some like representation style votes that we're more familiar with. Maybe like a company style vote where what is the decision that's going to like get us the most profit within the next year? That maybe has an objective answer. We're not sure what it is, but there is like an underlying better and worse one. And in Condorcet's model, voters are going to independently choose the correct outcome with some fixed probability p, hopefully above 1/2. And this was actually before the law of large numbers, I think, or he sort of derived this all on his own. But his big contribution was like, okay, as the number of voters grows large, if you just take the majority, so standard direct democracy, you ask for take the outcome that received a majority of the support, then you'll get the correct answer with probability that approaches 1. So from Condorcet's view, like direct democracy is fantastic. Like it sort of immediately gets like the best thing we could hope for. We're getting the correct outcome. So how can we frame liquid democracy in a similar way? And actually, our goal will be to sort of use this framework to compare the performance of liquid democracy versus direct democracy. And this dates back to, this is actually the journal version. So I think that some paper with my advisor and other people in the lab from maybe like 4 or maybe 6 years ago. So again, we'll have n voters. One first difference is we'll assume some heterogeneity in the populations. People have different expertise levels. This will be like the probability that they get the correct answer. So it's just some value between 0 and 1. If you look at one of these delegation graphs, that's what I was showing you in that first slide. Who's delegating to who? Just draw an arrow from among those things. You can directly compare using this framework the probability that direct democracy is correct versus the probability that liquid democracy is correct. And we'll, sort of annoying notation, but we'll define like the gain on this instance, like how much better is liquid democracy versus direct democracy, or the difference in these probabilities, but which can be positive or negative, depending on which one's better.
In this setting,
yeah,
everybody votes, or sampling from possible voters.
So the assumption is that you could, this is like a counterfactual thing. Had everyone voted, there would be just a probability that direct democracy is correct based on the PIs. So it is in direct democracy, everyone's voting. In liquid democracy, given a graph, only the people that are like that don't have an outgoing edge will vote, but we can still compute this probability. Right. So just to give you an example of this, let's say we have this population of 7 people, and the blue people have expertise level 0.6, and the purplish people have level 0.8. So I can, trust me on this math here. If you just figure out the probability that if everyone votes, you get a majority being correct, about 82%. Let's say these 2 blue people delegate to people that are a little more experts on this topic, then you can figure out the probability that liquid democracy is correct. So right now, these people are voting with a weight 2, and these 3 people are voting with a weight 1, and we just want to see how often is the weight at least 4. So that would be a majority. And you can do the calculation. It's gone up a little bit, right? So the probability now is 0.84, so the gain here would be 0.02. Let's say more people delegate to this purple person. So now in this graph with all of these edges, we've actually lost a little bit. Even though it was people with lower expertise levels delegating higher, we sort of induced a lot of correlation because this person has so much weight that when they get it wrong, it's actually hard for the population to still get it right. Actually, I think they're anyways, right. So actually, sorry, they're actually like a dictator here. They have weight for themselves. So the only way that we are correct is if this person is correct. If they vote wrong, then the majority is necessarily wrong. So we've gone down a little bit. Now it's just 0.8. And if this person then delegates onwards to like an even lower person, things get even worse. So notice here the gain is actually negative. And we can go down quite a bit if the delegations don't go well. But if they do go well, it goes up. So this is a way that we can compare how good each of these systems are. So just to get a little more intuition, some extreme examples. Right, you sort of have like a big star graph like this, where some lower, people that are less experienced are voting to like a very smart person in the center. Then with direct democracy, the probability of being correct is going to go to 0. You'll have all these like 0.1 people that only about 10% of the population is going to be right. But if they all delegate to the center, you at least get this constant chance at 0.8. As long as the center person's right, we're okay. But in a very similar looking example, if the outside people now have correctness probability of 0.6, now direct democracy does fantastic because this probability is above 1/2. But the center person still is only getting it right, probably 0.8. So here the gain, we've lost a little bit. So even though these look very similar, they sort of diverge in quality. But I think the main takeaway here is that like how well liquid democracy performs is just hugely dependent on the behavior of voters. Who are they delegating to? How often do they delegate? There's sort of like a very careful balance where things go better and some where they go worse. So the only way we can really analyze this is by having a model of how people vote and saying, under these models, what happens. So I'm just going to brush over these things. In the original paper, they defined a different behavior. We're going to define our own behavior that we think is a little more realistic. I'll even back it up with some experiments. So I'm going to brush over this really quickly.
Question.
Yeah.
All of the bad examples really involve very small number of delegates, like 1 maybe. Doesn't that go away once you have even a slightly larger number of independent samples from experts?
Yeah, I mean, if you have many experts, then it's okay. But you might have more people that are below 1/2. There's lots of ways that things can go wrong. I mean, sure, if you had many of these 0.8 situations, then yes, things would be okay. But maybe that doesn't happen. So hopefully that does happen, and then you're okay. Right. But the main thing that we want to say is, when is liquid democracy actually good with respect to behaviors? Don't get too bogged down in the notation, but essentially, like, if you have behaviors whereas the number of voters goes large, the gain is not too bad. So this is called do no harm. So for any epsilon, if you have enough voters, it's not going to be too much below 0. And conversely, we sort of want to say like at least it's doing something, right? So basically, like there are models of there are situations where under this voting behavior, things sometimes go better. So there's like a constant above zero, where with like enough voters, you will actually get a substantial gain sometimes. These are sort of two like somewhat minimal properties that we'd hope for to say that liquid democracy is outperforming direct democracy with respect to this model. Yeah.
Is it built in these estimates that voters always delegate to somebody more expert than them?
So the negative result here is yeah. So the result from the last paper is that like yes, there is actually no way to satisfy both of these, and this is even assuming that people are only delegating to people with higher expertise than them. So it makes it an even stronger negative result. It's like even assuming this, we can't get things that are good. Right. Okay, so yeah, we'll get into the details of this. Sort of, it's some like local people are only deciding based on who they see at a social network. But yeah, I don't want to get into the details of the last paper. The main problem again is exactly the extreme examples I was showing. Sort of any of their models of voting behavior, there are always instances where some voters were getting like a constant fraction of the votes. Right, and just like those extreme examples before, just like you mentioned, like ideally you'd have a few of these people, but if there's just very few of them, things don't work out too well, right? You'd much rather have like a big society of 0.6 people than just like a constant number of 0.8 people. Those people will get it wrong sometimes. And they offered a few solutions to get around this negative result. Essentially, if you can like forcefully cap the number of delegations that someone receives, so, like, they already received this many delegations, let's like not allow them to get any more, then things can work well. Alternatively, in a different follow-up, they considered when maybe you say like I'm okay with delegating to two different people. You pick between them. I'm sort of indifferent. Then you can sort of work things out, and it works out all right. Sort of power of two choices style thing. But both these things require the use of a central planner, sort of someone that like decides where delegations go, or adds some restrictions, which really is like fundamentally, I think, against the core idea of liquid democracy, right? Where it should be, you get to choose whoever you want. Like this is how this delegation works. So in the last few minutes, I'll talk about our work, and the main idea here is, maybe rather than focusing on fixes the essential planner, maybe let's go a beyond worst case approach and see like how often do these bad instances occur. Maybe under like certain assumptions on the voting behavior, they're very rare. So even though in principle it could happen, on average we'll be doing okay. And so our talk is titled "In Defense of Liquid Democracy." It's been received some negative press. Maybe we want to come back. Right, so we'll have a new theoretical model. This is work with my dad and advisor and a couple others. And we've actually even, Mano, my collaborator at MIT, has done lots of real-world experiments sort of to validate were our assumptions okay? Is liquid democracy actually doing better? And the answer essentially is yes, at least in like certain small examples. We're not saying this is like good on a society-wide, political scale, but like in small settings, we do believe that things should be going okay. So maybe they're not so bad. So it's a little technical to understand our delegation model. I'll try to discuss it briefly and then say it works, but I won't say much more than that. Right, so the key difference is how we describe delegation models. So our model will be made up of two parts. This looks very notation heavy. So let me get to the example, which will make it more clear. So let's just say people have these expertise levels of P1 through Pn of the people in the population. So the way you're going to decide how to delegate, this Q function sort of tells you how likely you are to delegate, right? So if you have a certain competence, Q of Pi tells you how likely. So you first sort of flip a coin, am I going to delegate at all? And then who you delegate to depends on the SPI function. You sort of like put weights on other people, and you delegate to them sort of proportional to the SPI. And the idea is not that this is actually what people are doing. They're not actually flipping coins. This is sort of like a population-wide thing. Like on average, are people who have expertise level 0.8, how likely are they to delegate, right? Like when they do delegate, sort of are they on average delegating to people or more that are 0.9 or 0.7, right? So just sort of capturing all these things, but like once we have parameters for these functions, we can sort of simulate the whole process, fix expertise levels and sample whether a 0.8 person will delegate, sample who they delegate to, and so on. And the big assumption here is this will be done independently, but yeah, but I'll show you an example of how it works. So let's say we have these two functions. We fit these two functions. We think this is how delegation occurs. So you delegate with probably like 1 minus your expertise level, and who you delegate to is proportional to 25 p squared of that person. And with these confidence levels, and the reason I chose these functions is that if we take the perspective of this blue person, so first they choose to delegate with some probability, 2/5. And if they do delegate, they put these weights in everyone else, and they very conveniently add up to 100. So these are the percentages they might delegate to each person. You choose to delegate proportional to these weights. So maybe they delegate here, and so on. You just do this for everybody, and this is how you would sample like a real life delegation graph. And so just to give you some intuition about this model, sort of like the delegation only depends on your expertise level. The cue on how likely you are to delegate. So maybe if you feel more confident, you know the topic, you're less likely to delegate. Or maybe it goes the other way, like these like Dunning-Kruger style things. If you're less informed, you think you know more, and you're going to actually get to delegate anyways. And the phi is capturing the behavior. So maybe you delegate to people more similar to you, sort of at your level or higher up. And capture lots of things like this. And yeah, additional assumption is that these levels are drawn just IID from some distribution, right? And you can I'll breeze through this, but you can sort of redefine the exact same things in a sort of pack learning probabilistic style way, right? The gain isn't too bad with some reasonably large probability. And these both approach one.
Just for intuition.
Yeah.
In this setting, there is some presumably small but non-zero probability that everybody delegates to the single person who's the lowest.
Yes. So that's the delta, right? So for any delta, if you have enough people, that's going to happen with extremely small probability, but we can't rule out that possibility. So the main positive results here is that under like large classes of voting behavior, we get both of these properties, which was seemingly impossible in the other setting. And the first one's kind of a toy model, but the second ones are sort of what you think they should be, which is that like let's say that this is they call it confidence based. If the higher expertise level, the less likely you are to delegate. So this means smarter people are like I'm confident in myself, I will vote. Things work well here. And similarly, like if when you do delegate even if everyone delegates with the same probability, if when you do delegate, you tend to delegate to people with more expertise, not always, not deterministically, but you're just placing slightly higher weight. So it's just some increasing function, then things work out okay. And these again seem intuitively obvious. I won't get into like the proofs, but they get like surprisingly nasty because you're doing all these like stochastic process things. You need to make sure that people aren't receiving too much weight to cancel out the benefits of delegating to the higher people. In the last couple minutes, let me briefly mention some experiments that Manoa ran. So she went to several classrooms, companies, or different settings that might be used, and asked people to fill out these surveys. They'd be asked like lots of, again, objective questions, which is the things that we're measuring here. So you'll be given a bunch of like English idioms and asked to identify their meaning. And within these settings, you were asked like, would you like to directly vote on this topic, or would you like to delegate your vote to someone else? And we really wanted to do this in settings like classrooms where you might be familiar with other people. You might know who the experts are, which is where liquid democracy seemingly does well, right? It's when you can when people are able to, maybe they don't know the topic at hand, but at least they're able to identify people that they think will be good, right? You can delegate to good people, and you really need to know people in this environment for that to work well. Right, and from this we can look at lots of sampled graphs, and I guess hard to say like, is this bad concentration of power or not? I mean, we did the math, but the graphs look somewhat reasonable. It's not just like all the one person, usually sort of somewhat spread out, which is good. And you can try to fit these functions, and you can see on average, people with higher expertise levels were actually less likely to delegate. And on average, they tended to be delegating higher people. This is somewhat of an old analysis. We have some more recent analyses that have higher statistical power and are a little more in depth. But the general takeaway is like, yes, things like really do work well. We see an actual like improvement, which is very exciting. Right. So just some general takeaways is like, liquid democracy is like an exciting new paradigm that people really have been excited about over the last 20 years. And it has other intangible benefits, right? And I'm talking here just about this accuracy thing, but there's lots of ways in terms of like legitimacy and people feeling like they get to participate that I'm not talking about here. but the problem was, prior work said like if you are going to use it, you might have a couple reservations toward like its impact on accuracy. Within this one model of voting, things don't work out too well, right? There are bad instances. And so our response to this is like actually maybe things are okay under like our delegation behaviors, which we think are somewhat realistic. We have good performance, and so at least in this dimension, you should be okay. And maybe go ahead and try liquid democracy, and right, the experiment support. So just to wrap up, obviously there's lots of additional things you can add to this. It's not a perfect model. Things like social networks and independence. And considering things other than just accuracy, but I'm just very excited about the paradigm itself and what else we can study and what else we can do with it to see it actually being used. That's all I have. Thank you.
Yeah.
What's that?
It seemed like the definition of local. There's sort of two ways a liquid democracy protocol can be local.
Mm-hmm.
One is everyone makes their own choice separately. The other is that there's like a network of who you're aware of, like you're saying.
Yeah.
And they're sort of separate in the sense that I could have a network who are only aware of people, but I could then have a central planner who assigns you people on that network.
Mm-hmm.
So like, is the idea to sort of have both of those?
Yeah, the idea is to eventually have both. We're kind of hoping that the models. I mean, you could imagine it like sampling a network as part of this. You can pretend that the phi really is like you're sampling your neighbors and then sampling after that. The original work did have a social network, so like the worst case results were like there is a bad social network where under their definition of local things did poorly, and their definition of local was exactly this, sort of like everything was a function of your neighborhood. Although sort of everyone had the same. If you saw the same neighborhood, then your behavior was the same.
So are the original negative results? Do they also hold when there's a complete graph as the social network, but you have to make your own decision without coordinating vote?
No, right. So I think their negative result was exactly like there are bad social networks. Sort of like whatever your behavior is, we can construct a worst case social network. Peter?
Yeah, your last example, this real world example with the go back to that slide. No, where you show the results.
Yeah.
Yeah, there we go. Yeah, so what you're showing here is how people delegated, but you can also measure the outcome.
Yes, we yeah.
In other words, do people correctly identify experts, or
Yes.
are they choosing their delegation based on other factors, their friends or
So these are some older graphs because I just had an old talk from last year. We have some new graphs that exactly look at this. Like as of like last Monday, we had a meeting. So I didn't include those new ones, so there's still a little bit of a work in progress. But we exactly look at how often is the majority correct? Obviously, like a very important question. Some of these like the questions are like too easy. Like the majority is almost always right because it's just an easy question, or it's too hard. Maybe you can ask for different thresholds, but we exactly look at these questions and how often people are identifying experts.
what do you find?
No, I mean, generally very positive things. Sort of, it is performing better. I mean, there are cases where it performs worse, and we have stories for why in these situations it shouldn't be as good. But like the general takeaway is like in most settings, things are very positive. Alan?
Things are usually in political situations. People are very good at gaming whatever the system is to make it work for them. This reminds me of proxy voting in shareholder voting, and in that case, usually the company that is having the annual meeting gives you the list of people who are going to be the proxy you delegate. It's basically the company approving itself.
Yep.
If you had this done in a political context, I should imagine that there would be people who are members of political parties who are going to be these well-educated, knowledgeable delegates, and it'll end up being partisan as usual.
Yeah, I agree. So I'm definitely not advocating like implementing this on like a very large scale because I'm worried exactly these things. We had a project after like exactly trying to think about some models of like being robust to adversary, like things like this, being robust to coercion, which we called it. If I'm able to force people to vote for me, like how much power can I induce? So that's why I'm like more focused on smaller stake things where hopefully it's not as big of an issue, but it is a concern for sure.